Here, f of x is defined for all x within the range -1 to 1. Can we say anything about existence of limit when x equal to when x is tending to 0 for this function f of x? We cannot say this. For example, we have defined this function, greatest integer function of x. Okay, it becomes like that, right? From 0 to 1, it will be 0. From 1 to 2, it will be 1. From 2 to 3, it will be 2, likewise. Now, this greatest integer function, when limit x is tending to 0, what does it mean? When limit x tends to 0, there has to be a limit. Then that means if you are going from the left side, as we are approaching 0, when x is approaching 0, f of x should approach some number. Let's say that is L. But here, when x is approaching 0, when x is approaching 0 from this side, f of x is approaching -1. When x is approaching 0 from the right side, f of x is approaching 0, there is no common number, right? If limit x has to exist, then when x is approaching 0, f of x should approach that common number, some L. Here, there are two different numbers. There is a break here. So and here the function is perfectly defined, right? Perfectly defined, not just for -1 to 1, for the entire real numbers, right? For example, f of 1 is 1, right? Greatest integer function of 1 is 1. Greatest integer function of 1.9 is also 1. Greatest integer function of 2 is 2. Like this, the function is properly defined, but still limit doesn't exist, right, guys? It is not about the definition of the function. It is about whether at that point the value of the function from both the sides is coming out to be same or not. Right. Next one. Here in this case, again, limit x tends to 1, f of x equal to 5. This is given. Okay, that means if I are approaching x, this function is approaching 5. Whether you are approaching from the left, from the right, the value of this function is approaching 5. Okay. Now, does that mean this function has to be defined at x? No, it need not be. For example, let's take this function x square plus 3x minus 4. What does that mean? X square plus 4x minus 4. The numerator, that is x into x plus 4 minus 1 into x plus 4. What does that mean? What is this function? X minus 1 into x plus 4 by x minus 1. Okay. So this function is actually, we can cancel this x minus 1, as long as x is not equal to 1. When x is not equal to 1, this function is equal to x plus 4. So this and x plus 4 are identical functions except when x equal to 1. Okay. So the graph of this function is equal to x plus 4. When x is 0, it is 4. When x is 2, it is 6. It is equal to x plus 4 except when x equal to 1. Except when x equal to 1. So this point will be missing. X equal to 1. If it was x plus 4, we would have got 5. But because x equal to 1 is not there in this domain, we'll skip this and we'll call it a whole. Okay. This point is actually whole. So basically this function g of x is not defined when x equal to 1. But what is the limit? Limit is still 5, right? Limit of g of x is still 5 because if you are moving from the left, x is moving from the left, that means x is approaching from left to 1. Then what is the function approaching? The function is approaching 5, right? When we are approaching x from the right, the function is still approaching 5, right? As x is going closer to 5, x is going closer to 1, f of x is going closer to 5. But that doesn't mean this function is defined, uh, this function has to be defined at x equal to 1. So in this case, the function is not defined at x equal to 1, right? So definition of function at the particular point has nothing to do with the of limit at that particular point. Limit means that point, if that point has a limit, that means the function should approach that point when x is approaching that particular x naught. Okay, at this x naught, if this is the limit, what does that mean? When you are approaching the x naught from the left or from the right, the function should approach that particular point. Okay, so that's why This is not needed. Definition of function at 1 is not needed. Let's take this another case. Here we are given the function is defined at 1. Okay, f of 1 is equal to 5. So does that mean limit x tends to 1 f of x exists? It need not be. For example, let's again take this function, greatest integer function of x plus 4, something like this. The function is definitely defined at 1, at 2, is defined over the entire real one, right? So 1 to 2, it is equal to 5. This is definitely defined at f of 1 equal to the definitely defined over the entire real line, and definitely f of 1 is equal to 5. But limit doesn't exist, right? Need not be, because when x is approaching 1 from the left side and from the right side, when if it is approaching from the left side, we are getting 4. If I are approaching from the right side, we are getting 5. Both are not same. So both have to approach the same number. So limit x tends to need not exist. Okay. Then if at all it exists, limit x tends to f of x equal to, should it be equal to 5? That is the question. If at all it exists, then does that mean that the value of this function or limit x tends to 1, f of x should be equal to 5 or not is the question. This need not be, right? So the previous case is also similar thing. Okay. So here, f of 1 is 5, but f of 1 you can define anything. But the function you can always define something like this. Something like this. Something like this. Here you can put a hole. The function is approaching this point. But f of 1 you can always define as 5. Only that point you can always define. So for example, here in this case, here f of 1 you can define as 2. Right, f of 1 you can define this point as 2. G of x is this thing. And when x equal to 1, g of x equal to 2, when x equal to 1. You can always define a point like this. But still, the limit of this function is still 5. Limit when x tends to 1 is still 5. Though you forcibly define the function when x equal to 1 as 2, it doesn't matter. So similarly in this case, f of 1 could be anything. That is your definition. F of 1, you can break this here and you can define anything. But limit x tends to 1. Limit x tends to 1 is when you are approaching 1, how the function is behaving. When you are approaching 1. When you are approaching 1, what is the value the function is approaching from the left side and from the right side. It has nothing to do with what is happening at f of 1. Right, f of 1 can be 5, but limit can be something else. Right, f of 1 can be 5, f of 1 can be 10, but limit can be something else. Limit depends on how the function is moving when you are approaching from the left, from you are approaching from the right. F of 1, you can decide whatever you want. Right, guys? Hope you like this. Thank you.